All right, let's look at some examples. On the handout that was given to you, it's a copy of a couple of textbook pages, and we're going to work through some together. And then I'm going to give you some to work on your own based on the examples that we do together. So if you take a look at number 1, you are solving a right triangle. And so to solve your right triangle, you use the information that's given in order to identify the pieces of information that you need to find. So we're given this triangle ABC, and we're told that the measure of angle A is 41.5 degrees, and we're told that the measure of length little b is 20. So what we are charged with finding is the measure of little a and the measure of C, in addition to the measure of our angle B. Well, the measure of angle B is the easiest of the 3 to find because we know that the 2 acute angles of a right triangle are going to be complementary. So I just take the measure of the angle that's given to me and I subtract it from 90, and this is going to give me 48.5 degrees. Now, to find A, I'm going to use the pieces of information that are given to me. So A is my opposite side, and I'm given the adjacent side to the angle. So I'm going to use tangent, and what I know is that the tangent of 41.5 is equal to my opposite side A over 20. So that means A has to be equal to 20 times the tangent of 41.5. So I'm going to let my calculator do that work for me, making sure that my calculator is in degree mode. And so I have 20 times the tangent of 41.5, and this is going to give me approximately 17.69 for my length. The directions, I believe, tell you that you need to round off to 2 decimal places for your lengths and 1 decimal place for your angles. In a similar way, I'm going to solve for my hypotenuse C. I'm given the adjacent side to the angle, and my hypotenuse is what I'm looking for. So adjacent and hypotenuse, I'm going to use cosine. So I know that the cosine of 41.5 is equal to 20 over C. So that means my C is going to be equal to 20 divided by the cosine of 41.5. So I have 20 divided by the cosine of 41.5, and this is going to give me C is approximately equal to 26.70. Okay, and number 11, this is a really common situation that you'll find on a lot of exams, where they give you 2 side lengths and you have to solve for the 2 angles and the remaining third side. So with this, I'm told that the measure of side B is going to be 2 and my hypotenuse is 7. I have to find angle A, angle B, and side little a. Well, I can find side little a rather quickly because it's just the Pythagorean theorem. So I know that 7 squared has to equal a squared plus 2 squared. So I have 49 is equal to 4 plus a squared. And so 45 is equal to a squared. And when I take the square root of both sides, then I end up with a is approximately equal to 6.71. Now, to find my angles, I'm going to use an inverse trig function. So to solve for angle A, I have adjacent and hypotenuse, so I'm going to use the inverse of cosine. So the measure of angle A is equal to the inverse of cosine for 2 over 7. So this gives me the measure of angle A is approximately equal to 73.40 degrees whenever I round off to the nearest hundredth. And then I can either subtract that from 90, or I can use the inverse sine function for the same ratio to solve for B. So when I do that, then you end up with approximately 16.60 degrees, which is what I would expect to find since I had 73.4 for my other angle. Now in number 13, you are dealing with some directional bearings and writing the directional bearing. So you are given this angle in the plane, and we're dealing with directional bearings, so we always have to use the acute angle with the north-south line. So I need this angle in order to write my directional bearing, which is going to be the complement of 75, which is 15 degrees. So my bearing is going to be north 15 degrees east. And then for number 15, in a similar fashion, I'm given this angle in the plane, and we always have to use the angle with the north-south line, which is the angle given to us this time. So our directional bearing is going to be south 80 degrees west. Now, in 17, you are asked to write the equation of the simple harmonic motion. So this is going to really solidify what those equations kind of represented. So you're dealing with a spring that is being pulled from its rest position down. And then you're told what the amplitude is in the table and the period of the cycle. And so for 17, you're told that your period is 4 seconds. So if our period is 4 seconds, we know that the period is equal to W 2 pi divided by W. And so if our period is 2 pi divided by W, then 4 is equal to 2 pi divided by W, and I solve for W. So that means W is going to be equal to 2 pi over 4, which is just pi over 2. So that means my equation, D, is equal to, since I start, according to my table, at 6 centimeters below my rest, that means I'm starting above or below my rest line, so I'm going to use cosine. And since I start below my rest line according to the directions, I have a negative starting position. So even though they tell me that my amplitude is positive 6 centimeters, I'm starting below the rest line. So that represents a negative 6 distance times the cosine. And my W we found to be pi over 2 times t time. And that's all you do. That's the equation. For number 19, very similarly, I am told that my period is 1.5 seconds. So if my period is 1.5 seconds, and I know that the period is 2 pi over W, then to solve for W, I take 1.5 is the same as 3 over 2. So I have 3 halves is equal to 2 pi over W, and I solve for W. So this is going to give me W equals 2 pi divided by 3 over 2, which is going to simplify into W is equal to 4 pi over 3. And since in this scenario I start at a resting position, I have D is equal to negative 5 times the sine of 4 pi over 3 times T. And in 23, you are still dealing with simple harmonic motion, and you're asked to find one, the displacement, which is your amplitude. So the absolute value of A is going to be 6, and we're dealing with inches. My frequency, because my frequency is W over 2 pi, well, W in this case is 2 pi. So I have 2 pi over 2 pi, which is 1. And my period is going to be 2 pi over W, which is 2 pi over 2 pi, which is also going to be 1 second.